Good morning. Today we are going to do 1-4, which is adding probabilities. The key word you are looking for when we talk about adding probabilities is or. Anytime we see or, that means we are going to add. So yesterday, if you'll remember, we did multiplying probabilities. And the key word we look for there was and. And equals multiply or equals add. If two events A and B are mutually exclusive, that means they cannot occur at the same time, then the probability of one event or another event happening, so the probability of A or B is the probability of A plus the probability of B. So if we look at example 1, it says Keisha has a stack of 8 baseball cards, 5 basketball cards, and 6 soccer cards. If she selects cards at random from the stack, find each of the probabilities. So first thing we're going to do is add them all together and realize she has 19 cards. So the first one I want is the probability of baseball or soccer. Well, the first thing I look at is, can baseball and soccer happen at the same time? No, it's either a baseball card or a soccer card. Therefore, they are mutually exclusive. So the probability of a baseball card is 8 out of 19, and the probability of a soccer card is 6 out of 19. And when we add fractions, we add the numerators and keep the denominators as long as they are alike, and we get 73.7%. Number 2, football or basketball. Again, football and basketball are not the same thing. But if you look up here, we do not have, or she does not have any football cards. So the probability of football is 0 out of 19. Plus the probability of basketball, which is 5 out of 19. Since we're not multiplying, that 0 doesn't affect my probability. I still have a probability because it's football or basketball. So this, when we add the tops, I get 5 over 19, which is 26.3%. On to B. A card is drawn at random from a standard deck of cards. Determine the probability. A 6 or a king. So can it be a 6 and a king at the same time? No. So the probability of getting a 6 is 4 out of 52, and a king is 4 out of 52. Remember, if you're not familiar with the deck of cards, either pull one out or look at the deck of cards sheet that I posted on the top of my website. So this gets me 8 out of 52, which is 15.4%. Finally, red or black. So there are 26 red cards. Again, they can't be red and black at the same time. And there are 26 black cards. So that means it is 52 out of 52, which is a 100% chance of happening. So let's take a look at what we mean by inclusive events next. So if two events, A and B, are inclusive, that means the two events can occur at the same time. So the probability of those events occurring is the probability of A or B, which is the probability of A, plus the probability of B minus the probability of A and B. In other words, we double counted something, so we have to take out what we double counted. And let's take a look at the examples, and hopefully it will become clear. So the enrollment at South High School is 1,400. Suppose 550 students take French, 700 take algebra, and 400 take French and algebra. So first thing I'm going to do is I'm going to go ahead and draw a Venn diagram. So remember, those are just two overlapping circles. So this is my French. Here is the algebra. So there's 400 students that take both. So they have 400 shared. 700 take algebra. That means there's 300 left that take algebra but not French. So we had to do 700 minus the 400 to get the 300, because these two need to add up to the total number of students taking algebra. We're going to do the same thing with the French. So 550 minus the 400 that we already have in there is 150. So we're going to use this information. So French or algebra. So that's how many take French total plus how many take algebra total minus, now these 400 I counted in both the French and the algebra, so I need to subtract out the 400 that I double counted. So when we add those all up and subtract, I get 850 over 1,400, which is 60.7%. So a card is drawn from a standard deck of cards. Determine the probability, a queen or a diamond. So the thing I want to look at is, can I get a diamond that is a queen? Those are double counted. The answer to that is yes. Therefore, they are inclusive events. So to do this, we're going to do the probability of a queen plus the probability of a diamond. But then I need to subtract the probability that I have a queen that is a diamond. So there are 4 queens in the deck. There are 13 diamonds in the deck. And there is 1 diamond that is a queen, because I counted it both in queens and in diamonds. So I can't count twice. It only happens once. So I get 16 over 52, which is 30.8%. Black or ace. So the probability that I have a black card plus the probability I have an ace minus the probability that I have a black ace. And yes, that does. So we ask ourselves, can I have a card that is both black and an ace? Yes. So we double count it in both spots. So the total number of black cards I have are 26 over 52, plus the total number of aces I have are 4 over 52, minus I have 2 black aces, the spade and the club. So they were included in both. I need to subtract them out. So I end up with 28 over 52, which is 53.8%. So let's take a look at example 3 next, and this is where we are going to pull 2 cards, not just one. So just like in the previous sections we have done, anytime we are doing more than one, so pulling 2 cards, we are going to use NCR. We're going to use combinations. So here I want to pull 2 kings or 2 black cards. So we need to do the probability of 2 kings plus the probability of 2 black cards. And we need to ask ourselves, can I pull a black king? Yes, I can. So I need to subtract the probability of pulling 2 black kings. So there are 4 kings to choose from, there are 4 kings to choose from, and I want to choose 2. So it's going to be 4 choose 2 over, of course, it's 52 choose 2 on all of these. Here I have 2 blacks, so I have all 26 black cards, so 26, I want to choose 2. All over 52, choose 2. And how many black kings are there? There are 2. So I'm going to 2, choose 2. All over 52, choose 2. So this ends up being 6 plus 325 minus 1. All over 1326, which is 24.9%. Okay, B, the probability of 2 8s or the probability of 2 jacks. And the question is, can they be an 8 and a jack at the same time? No, they cannot, so I have nothing to subtract here. So the probability of pulling 2 8s, I have 4 8s in the deck, and I want to choose 2. And here I have 4 jacks in the deck, and I want to choose 2. It's me 6 plus 6 over 1326, which is 0.9%. Okay, both 3s or less than 5. So I want to say, is there any way to pull 3s that are less than 5? Yes, 3s are less than 5. So this one these are inclusive, and therefore I'll have to subtract. So the probability of 2 3s, the probability of 2 that is less than 5, minus the probability of 2 that is less than 5 and 3. So, how many 3s do we have? I have 4. So less than 3, that would be 2, 3, 4. 5 is not less than 5, so I can't use that. So it's 2, 3, and 4. I have 4 of each of those, so that gets me 12. And what's my only number that is less than 5 and a 3? Well, that is 3. And I have 4 of those. So I end up with 6 plus 6 plus 66 minus 6 all over 1326, which is 5%. And the last one here, 2 face cards and 2 red. So the question is, can I have a face card that is red? Yes, I can. So these are inclusive events. So I want the probability of 2 face cards plus the probability of 2 red cards minus the probability of 2 face red cards. So remember, face cards are your Jack, Queen, and King. There's 4 of each of those, so that is 12 choose 2. Red cards, I have 26 of those, 26 choose 2. And two red face cards, so half of these were red. So the other half were black, so that means I have 6 red face cards. So 6 choose 2. So I end up with 66 plus 325 minus 15 all over 1326, which is 28.4%. And if you were choosing 3 cards, 4 cards, you would do the same process. So let's take a look at example 4, which is where we're going to look and decide whether they're inclusive or exclusive events. So can they happen at the same time? Inclusive, exclusive, they can't. And then find the probabilities. This is where they're all mixed up. So 4A says there are 3 literature books, 4 algebra books, 2 biology books on a shelf. If a book is randomly selected, what is the probability of selecting a literature or an algebra book? So the first thing I ask myself is, can it be both a literature and an algebra book? It cannot. So these are exclusive. So the probability of literature or algebra, so I just add them up. So the probability, there are 9 books total, so it's over 9. 3 are literature, 4 are algebra. So that is 77.8%. If I read B, a die is rolled. What is the probability of rolling a 5 or a number greater than 3? So we ask ourselves, can 5 and a number that greater than 3 happen at the same time? Yes, they can. Because 5 is a number greater than 3. So these are inclusive. So the probability of 5 or less than 3. So that means the probability of 5 is 1 out of 6. The probability of greater than 3. So greater than 3 means it can be a 4, a 5, or a 6. So that can happen 3 out of 6 times. minus the probability that it is a 5 that is greater than 3. So how many times does 5 greater than 3 happen? Once. So this is 3 out of 6, which is 50%. And C, it says in a math club, 7 of the 20 girls are seniors, 4 of the 14 boys are seniors. What is the probability of a randomly selected boy or senior to represent the club at a statewide math contest? So can a boy be a senior? Yes. Therefore, these are inclusive. So the probability of a boy or senior will be probability of a boy plus the probability of a senior minus the probability that the boy is a senior. So probability of a boy. First of all, we need to look at how many total senior or total members there are. So 7 of the 20 girls are seniors and 4 of the 14 boys. So that means there are 34 kids total. And how many are boys? 14. Plus the probability that they're seniors, that's 7 plus 4, which is 11, minus the probability of that they are a boy and a senior. So that is 4. So I end up with 21 out of 34, which is 61.8%. Let's look at D. Okay, D deals with all of these shapes over here. So there are 14 shapes total. What is the probability of picking a circle or a heart? So first of all, can it be a circle and a heart at the same time? No, it cannot. So these are exclusive. So the probability of a circle or a heart. So how many circles do I have? Count them up. I have 5. And how many hearts do I have? I have 4. So that is 64.3%. The second one was the probability of picking a triangle or a blue token. So I need to ask myself, do I have any triangles that are blue? I do, therefore these are inclusive. So the probability of triangle or blue, so that's going to be the probability of the triangle plus the probability that it's blue minus the probability that I have a blue triangle. So the triangles, there are 3 of them. The blue, there are 4 of them. And there is 1 blue triangle. So I get 6 out of 14, which is 42.9%. What is the probability of picking an orange or a hexagon? So is there any orange hexagons? Yes, there is. So this is inclusive. So I want the probability of orange or hexagon. So that's going to be the probability that it's orange plus the probability that it is a hexagon minus the probability that I have an orange hexagon. So the orange tokens, I have 2 of them. Hexagons, I have 2 of them. Orange hexagons, I have 1 of them. So I get 3 out of 14, which is 21.4%. Number 4, what's the probability of picking a blue heart or a green triangle? Can it be a blue heart and a green triangle at the same time? No, it's one or the other. So therefore, these are exclusive. So the probability of a blue heart or a green triangle is simply the probability of the blue heart plus the probability of the green triangle. So blue hearts, I have none. Green triangles, I have 1. So it's 1 out of 14 chance, which is 7.1%. And finally, the last one of this section, picking a red or yellow token. So can it be red and yellow at the same time? No, it cannot. Therefore, these are exclusive. So the probability of red or yellow, so that's the probability of the red plus the probability of yellow. There are 3 red tokens. There are 2 yellow tokens. So that is 35.7%. Let's look at the last few problems. E says 1 tile with each letter of the alphabet is placed in a bag and 1 is drawn at random. What is the probability of selecting a vowel or a letter from the word equation? So first of all, we have to decide, is there a vowel that is also in the word equation? Yes, there is. Therefore, these are inclusive events. So I'm looking for the probability of having a vowel or letter from the word. So that means I'm looking for the probability of having a vowel plus the probability of the letter from the word minus the probability of a vowel from the word. So there are 5 vowels in the alphabet, and there's 26 letters, A, E, I, O, and U. There are 8 letters in the word equation. And the word equation happens to have 5 vowels in it. So this ends up being 8 over 26, which is 30.8%. If I look at F, it says there are 7 girls and 6 boys on the junior class homecoming committee. A subcommittee of 4 people is chosen at random to decide the theme of the class float. What is the probability that the subcommittee will be 3 girls or 2 boys? So can they have girls and boys? Are they the same? Can you be a girl and a boy at the same time? No. So these are exclusive events. So if I have the probability of 3 girls or 2 boys. So that would be the probability of having 3 girls and 1 boy, plus the probability of having 2 boys, and then you would need 2 girls because it has to have 4 people on the subcommittee. You are choosing more than 1. I'm choosing 3 girls. We have to use C's. So this becomes C. So I have 7 girls to choose from, and I'm choosing 1. Times I have 6 boys to choose from, I'm choosing 1. And that is all over 13 students choosing 4. Plus, I have 6 boys to choose from, I'm choosing 2. Times 7 girls choosing 2, all over 13 choose 4. I get 35 times 6 plus 21 times 15, all over 715, which is 525 over 715, and that is 73.4%. Last one, we have a Venn diagram. It says the Venn diagram below represents senior citizens and their music preferences. The number of senior citizens surveyed was 60. Determine the probability. So, we have 60 total in here, but if you add these up, you probably have more than 60 because some people I should say if we add them up, the number is less than 60 because not everyone is accounted for in here. They only put 3 different choices of music on here. Some people probably like to listen to others. So the probability of only Western, so if I look over here and I go to only Western, that is this right here, 6 out of 60. Or only classical, so only classical is 3. And I'm not going to worry about double counting or having to subtract or whether they're inclusive or exclusive because I'm going to just the correct spot on the Venn diagram. So I get 9 over 60, which is 15%. For B, classical or 1940s pop. So classical is this entire circle. So I'm going to add up all 4 of those numbers. I get 21 out of 60. Or 1940s pop, that is all of this circle. So I add those all up and I get 24. Now, is there a section where they were double counted? Yes, right here. So I need to take those away because I counted them in both circles. So this ends up being 34 over 60, which is 56.7%. And the last one, classical and Western and 1940s pop. That means I am looking for where all 3 circles overlap. That only occurs in one place, this right here. That is who likes all 3 of them. So it's not ors, they were ands. So this is 6 over 60, which is 10%. Again, like always, if you have questions, make sure you ask. See you again tomorrow.